Here we are going to see today we are going to see about the continuation of unit 4. So let me see the what are the topics today we are going to see one by one. So first thing, that is the most common number systems. So there are in earlier days we have already read about that number systems. So in that number systems we have most common number systems. So that is the we already know that is decimal system, binary system, octal system and hexadecimal system. So there is decimal system. So decimal system means there is the 0 to 9. It should be represented by the base 10. Binary system is zeros and ones only we have to use. So it should be represented in the base as 10 2. Octal system, it should be from 0 to 7. The base should be represented in 8. And hexadecimal system, it should be 0 to 15. So that should be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, we have to mention in alphabetical. That is A, B, C, D, E, F. So its base should be represented as 16. So here how we have to convert the decimal to anything. How we have to convert. So let me see the one of the tabular form. So there is the number systems is here given. And if you have to convert it to the integer means how you have to convert. If it is a fractional means how you have to convert it. So let me demonstrate this decimal to anything by tabular column. So if it is you want to convert the decimal to binary means if the number is integer means you should be divided by 2. If the number is fractional means you have to multiply by 2. So decimal to octal means if the number is integer means you have to divide by 8. If it is a fractional means you have to multiply by 8. So next, if you are converting to decimal to hexadecimal means if it is integer means you have to divide it by 16. If it is fractional means you have to multiply by 16. So next is the analog and digital signals. So that is there are in signal level systems there are two types of signals. One is the analog signals as well as the digital signals. So digital signals should be in the digital values and analog signal should be in the sine wave magnitude. So there is the system should be having the physical quantities or the signals that may vary continuously over the specified ranges. So that is known as the analog system. Digital system means that is the physical quantities or signals that can assume only the discrete values. So that should be known as the digital system. So both having these greater accuracy level. So here we have shown the diagrams of analog signals as well as the digital signals. In the x-axis it should be represented in time and y-axis it should be x of t values. For that we have to draw the signal system. Next, base 10 decimal arithmetic. How we have to done the decimal arithmetic. So first uses the 10 numbers from 0 to 9. Okay. So first you have to use 10 numbers. Then each column will be represents of power of 10. Okay. So for example here one value is given, that is 1999 base 10. So first 9 will be the ones column. So it should be 10 power 0. Second value will be the tens column. So it should be 10 power 1. Third one will be the hundreds column. So it should be 10 to the power of 2. Fourth value will be the thousands column. So it should be 10 to the power of 3. So the values will become here. So 1 into 10 to the power of 3 plus 9 into 10 to the power of 2 plus 9 into 10 to the power of 1 plus 9 into 10 to the power of 0. So this will be the base 10 decimal arithmetic representation. Next is standard binary representation. So for standard binary representations means we have to use the two numbers from 0 to 1. So every columns will be represents the power of 2. So here one example has been shown, that is 1001 base 2. So first column will be first column will be 1's column, that is 2 to the power of 0. Second column will be 2's column, that is 2 to the power of 1. Third will be the 4th column, that is 2 to the power of 2. Fourth will be the 8th column, that is the 2 to the power of 3. So that will be added as 1 into 2 to the power of 3 plus 0 into 2 to the power of 2 plus 0 into 2 to the power of 1 plus 1 into 2 to the power of 0. So this will be the basic standard binary representation, how we have to add the numbers together. Here is the binary addition. So the column addition, that is 1 1 1 1 0 1, next 1 0 1 1 1. So 1 1 means 10, 1 1 means 10, 1 1 means 10, 10 plus 1 11, 1 1 10, 1 1 10, 10 minus 1 11, 1 1 10, 10 plus 1 11, 1 1 10, then 1. Okay, so this should be represented as 61 and this is 23. So 3 plus 1 4, 6 plus 2 84. For 84 we have get the values. So this should be the greater than or equal to 2 to the base 10. Next, decimal integer to binary conversion. How we have to convert the decimal to binary conversion, that is if it is a value is integer part. So first divide the number by the base 2, then take the remainder, that is either 0 or 1 as a coefficient. So next take the quotient and repeat the division again and again. So for example, if 13 is the decimal integer value, so for that we have to convert this value into the binary conversion. So that is first divide the base by 2. So 13 by 2, that is 6 is the quotient and 1 is the remainder. So take the remainder as a coefficient. So coefficient value A0 is equal to 1. Next 6 by 2. So that is 3 and 0. So 0 as the A1. Next 3 by 2. That is 1, 1. A2 is 1. Next 1 by 2. That is a 0 or 1. So it should be A3 equal to 1. So there is a A3, A2, A1, A0. So A3 will be the most significant bit and A0 is the least significant bit. So that is 1101. So this will be the binary value of the decimal number 13. Next, decimal fraction to binary conversion means. So you have to multiply the number by base 2. Take the integer as a either 0 or 1 as a coefficient. Take the resultant fraction and repeat the division. So 0. For example is given 0.625 base 10. So 0.625 into 2 we get the integer as 1.25. So take the coefficient as a integer value. So that is b minus 1 is 1 means 0.25. So that is into 2 0.5. b minus 2 is 0. So next is 0.5 into 2, that is 1.0. b minus 3 is equal to 1. So that is 0 dot b minus 1, b minus 2, b minus 3. So that is 0.101. This should be the value for 0.625.